Alright, in this video we'll take a look at taking your keyguard design to the next level beyond basic grid-based keyguard layouts. And what it will involve is adding concepts and cuts like these to your keyguard designs. So there are some additional objects that you can tell keyguard.scad to add to your keyguard. And these are examples of them. You can add rectangles, rounded rectangles, circles, large, small, with sloped edges or without, and this odd shape here, kind of a pill shape that we call a hot dog, for lack of a formal term. Then you can engrave things like text. You can create raised objects like bumps, the rectangular walls, horizontal and vertical ridges, and these raised elements are primarily there for people with vision impairments to aid them in the use of the keyguard, which is then aiding them in the use of their tablet app. So these are kinds of things you can put on the top surface of the keyguard, and you can put text on the bottom of the keyguard, and the way that's typically used is to put some sort of serial number on the keyguard so that you can find the keyguard definition or keyguard data somewhere easily based on that number should you need to replicate this keyguard. In order to take it to the next level, you'll need several things. First is you're going to have to use OpenSCAD. You can't use the Thingiverse customizer anymore for this level of design. And you'll have to download from the Files tab on Thingiverse. You'll have to download these, at least these 3 files, the ones that are marked here. The full version of keyguard.scad. You're running a light version if you use the Thingiverse customizer. Then 2 information files, one for case openings and one for screen openings. And you'll download these and put these in the same folder. So when keyguard.scad needs to go look for these, it looks for them in the same folder where it is located. And lastly, we'll take a real quick look at keyguard data, the keyguard data form, and you'll notice when you go to page 2 that there is some support there for this information, for creating custom cuts and putting custom 3-dimensional objects on your keyguard. So once you have downloaded keyguard.scad and these other 2 files, these 2 info files, you'll need to be able to open them in an editor. And on the website I recommend Notepad++, which is free, very functional text editor. But you can also simply use Notepad on your Windows machine or TextEdit on a Mac. When using TextEdit, you need to take an additional step to set the formatting properly so that you're not inserting special characters in the file. And there's information about how to do that on the website. So when you look at these files, and this text is small, I'm not intending for you to read it right here, but there's a region at the top that's just instructions for how this file is used. The meat of everything, both in case openings and screen openings, is at the bottom. These regions here at the bottom where you actually tell keyguard.scad what kind of shape you want, where you want it, what size it should have. And here are all the possible options that that are supported. Rectangles, circle and hot dog are really basically the same shape. It just depends on whether or not the height and width are the same, which is a circle, or whether the height and width are different. It's elongated in some way, and that makes it a hot dog. A rounded rectangle, outer arcs, and we'll look at those in a bit. Text on the top of the keyguard, text on the bottom of the keyguard, the bump, the wall, horizontal and vertical ridges. And this little table just highlights what information you should provide or can at least provide for each of these shapes. The shape column here shows you what text you'll put in this part of each file to indicate what shape you're talking about. So R stands for rectangle, RR stands for rounded rectangle. If you're doing a rectangle, for example, you have to provide its X and Y location, its width and its height. You have to put an R in that shape column. Then in the case of a rectangle, you can specify the slopes of the sides, and you can specify a different slope for each of the 4 sides of the rectangle. If you leave it at 90 degrees, you'll get a standard vertical cut. There are several shapes that use this corner radius column. Not always for a corner radius. Sometimes it's just for something else. There's some overloading here. And there are a couple things like bottom text and top text that will require you to provide information about what the text is that you want. We'll look at examples of that as we go here. And last thing I wanted to show you again is on that rectangle shape, you can provide a different slope for each side of the rectangle. So this is the bottom side, and we specified a 50-degree slope there, a 90-degree slope. It's hard to see that slope at this angle of the presentation of the keyguard. Mostly what I wanted to show you is that you can have a different slope on each side if for some reason you wanted to do that. And you can even undercut the keyguard by going beyond 90 degrees. Here's a slope that's 120 degrees, and it actually reaches underneath this plastic of the keyguard. So if you wanted to really hide something from the user but still provide access, you could do things like create these undercuts to get to it. So there are 2 files here. One is caseopenings.info and the other one is screenopenings.info, and they let you control different regions of the keyguard. So case openings controls the entire opening area of the case, and this file only has meaning if your keyguard is in a case. The other thing to note here is that when we're talking about X and Y locations, where to locate each cut, this is 0, 0 in that story. And all measurements using in case openings is in millimeters. When you're looking at putting things in screen openings, well, that's just the active screen area where the application can put information. So it's just this region here. And you have an option of defining where the 0, 0 should be for that. It can either be up here or it can be down here, and you'll specify that in keyguard.scad, whether it's the upper left corner is 0, 0 or the lower left corner is 0, 0. And we'll see why that's important here in a minute. And measurements for X and Y can be in either millimeters, as with case openings, or it can be in pixels. And if you're taking your measurements from a screenshot, pixels is the optimal way to go there. So that's the difference between case openings and screen openings. It's really the portion of the keyguard that they control. What I will have you notice, though, is that case openings includes that area that would be screen openings. So you could use the case openings file to define everything about your keyguard, including things you would put in the screen area. And if you're really diabolical, you can actually use screen openings to define objects that are out here outside of the screen just by using negative numbers or numbers that are larger or smaller, larger than the measurements of the screen. So we'll start by looking at case openings, and what I want you to notice here is this is a very special case. It actually has part of the case extends into the opening for the tablet. So this part in here, in order to design a keyguard that actually fits this case well, you have to account for the fact that this piece of plastic extends into what would otherwise be a nice rounded rectangular space. In particular, this is an iPad Air 2 tablet in a life-proof case. So what you need to do is take some measurements and just keep those on hand about where this little piece of plastic from the case extends into the keyguard area. So those will come in handy later when we're laying out our design. And also you may be able to see here that there's a darker region here. That's the border of the tablet outside of the screen region, and it's larger on this side than it is on this side. And you can account for that in the standard grid-based stuff under special actions. There are some parameters you can set, some options you can set for ensuring that your grid area is kind of pushed to the right to account for the fact that it's bigger here. We're also going to be designing the keyguard for this particular Go Talk Now application. All the standard stuff you're familiar with, a grid area, rows and columns of buttons, a lower command bar. This particular layout isn't using a message bar, but in this case what we'd like to do is hide most of this command bar but expose the home and back buttons. So we're going to make some rounded rectangular cuts in our keyguard to account for this. And with the standard grid-based keyguard Lite application, you could lay out everything here, but you'd have the choice of either exposing this entirely or hiding it entirely. And we want to kind of find a middle ground of exposing just part of it. And that's what makes this a hybrid keyguard. It's more than just a standard grid-based. It's hybrid because we're going beyond the capabilities of the basic grid-based keyguard. So this is what the keyguard is going to look like when we're done with it. We're going to have all the buttons exposed. We'll have the lower command bar basically hidden, except we'll have two rounded rectangular cuts here for the home and back button. In this case, we wanted to engrave the student's name in the top of the keyguard. We wanted to account for the place where that extra plastic from the case limited our design, so we couldn't simply go with a rounded rectangle shape for our keyguard. And we're also going to put a serial number on the bottom of the keyguard. In this particular case, it's the date where the keyguard was specified, and that might be how we keep track of all of our keyguards, is the date that we specified them. You don't see any special keyguard mounting options here, and that's because if we look back here, there's a fair amount of space on both sides of the keyguard, and we're just going to use microsuction tape, cut maybe 4 pieces that fits in this area and attaches to the underside of the keyguard. So this is what we're aiming to produce, including the underside with the serial number. And lastly, before we start doing that, I wanted to show you, if you look on page 2 of the keyguard data form, you'll see a table that looks like this, which is kind of what we discussed a moment ago. For every item that you want to add above and beyond a standard grid-based keyguard, you have to specify potentially multiple of these pieces of data. And there's a pull down here in the middle that allows you to specify what the shape should be. And we talked about those: rectangle, rounded rectangle, etc. So you have support in the data form for entering this additional information. Maybe again, this is something you keep on hand in case you need to replicate this keyguard at a later time, or modify it. Keep most of the measurements, but modify a few. I may have skipped over this. This actually shows you how we're going to handle this inset area of the case, and that is we're going to just put a rounded rectangle cut out here in the keyguard. It's going to be 90 millimeters tall, and it's going to be at a position which is 35 millimeters from the bottom, from 35 millimeters up, and 218 millimeters across in the Y direction. I'm sorry, in the X direction, 35 millimeters up in the Y direction, 218 millimeters across in the X direction. So with that in hand, let's begin to do some customization. Here's our keyguard already defined as much as we can without using the case openings and screen openings files. So it's the stuff that you could do easily with the Thingiverse customizer. And I'll also show you that we did make that accommodation for the fact that it's wider. The border is wider on this side than it is on this side. The distance here is 18 millimeters out, and so we set that in the unequal left side of case opening option here under special actions and settings. So to make this easier to do, I'm just going to minimize these two panes so I can more easily see what's happening as I add these cuts and additions to the keyguard. And we'll be able to see these happen in real time as we make changes to those files. So let's start with the case openings one. What we're going to do first is we're going to make that major cut for the case itself that surrounds the home button. And remember, we were going to create a rounded rectangle. So I'm just going to go ahead and overwrite this part here with a double R, rounded rectangle. And all the information here is still, the information is still up here if I need to refer to it. Then it has an X location of 218. Remember this, 218 here from 0, 0, 218 across, and 35 up. That's the lower right-hand corner, and that's where a lot of these cuts X and Y location is set at. And notice that my columns are getting out of alignment here. It really doesn't matter. The program doesn't care whether these are all nicely aligned. But if it helps you keep track of what you're doing, just do some deletes of spaces. So 218 millimeters across, 35 millimeters high. We have a rounded rectangle. We're going to make it about 20 millimeters wide, and we saw from this picture it needs to be 90 millimeters high. I'm also going to round it, well, because it's a rounded rectangle. I'm going to make the corner radius 5 millimeters. That can be kind of arbitrary. You can look and see what you think works best. Also, on a rounded rectangle, I can only set, let me see if I can get back to that. On a rounded rectangle, I set a single slope value, and that affects the slopes of all the sides. Because the corner round kind of ties everything together, you only get a choice of one slope. However, the outside of the key guard is 90 degrees anyway, so I can just leave everything at 90 degrees for this purpose. So it's going to ignore anything it doesn't need for this particular shape. Top slope is all it cares about. I'll leave that at 90. Now, how do I actually make that cut? So if I look back at my design, nothing has happened. How do I make that cut? I simply save the file. So OpenSCAD is looking for any changes in files that it cares about, and this is one of the files that keyguard cares about. So if I save this and go back now to the design, we see our cut. And we'll look at it here. We're going to add a little bit of flare here at the end, not right now, but I want to round these corners. I don't want them to be sharp 90s like this, and we'll use outer arcs to make those cuts, but we'll save that till later. And let's remember now what it is we were trying to accomplish. We want to put these two rounded rectangles in the bottom region. We want to put a bump right there between the second and third buttons on the bottom and first and second rows going up. And we want to put Eddie's name in the keyguard. So let's start with these buttons right here. And the easiest way to do that is to have a screenshot. And here I'm showing you, let me bring this down a bit so it fits better. Here I'm showing you Microsoft Paint. There are graphics programs you could use in Mac as well. I think I've documented those on the website. If not, I will soon. But the most important thing that the graphics program has to be able to do is show the full pixel image of the screenshot. And what you'll see down here is down in this portion, if you follow the mouse, there's a region that shows the entire how big is this screenshot. And on an iPad 2, it's 248 pixels wide and 1,536 pixels high. The other thing you need to make sure you have a screenshot that is all of the pixels. So just remember that, and don't do anything that would shrink the image, like embedded in an email message. Then as I move my cursor around the screen, and right now I'm over the top of the guy's head here in the upper left hand corner, and so it's a really tiny cursor, but as I move this around the screen, what needs to happen, and I'll be back here in a moment, I'm going to move the cursor down to the bottom right corner, bottom left corner of the screen. And if you watch down in this region down here, you'll see two numbers that change quickly. For example, right now there's a number 215, 80 px. The 215 is the x dimension, and the 779 in this case, or 80, is the y dimension, and they're measured from this corner up here. So if I move my cursor up to the upper left corner, they'll get smaller and smaller and smaller until they eventually go to 0. And it's hard to position it exactly at that point. But they get smaller as you approach this upper left-hand corner, and they get larger as you move to the lower right-hand corner. And in this case, I can't even see the entire screen I would have to change the view to shrink it. And now I can see the entire screen. That's another good thing to check, is to make sure that your screenshot captures everything available in the screen area. All right, so here are my buttons down here on the bottom. I'm going to zoom back out again. Scroll down. Here are my buttons in the lower left-hand corner. And what I just want to do is I want to get the location of the lower right-hand corner or lower left-hand corner. That's going to be my XY. And it's approximately, doesn't have to be perfect, around 252 and 252 in the X direction and 1493 in the Y direction. So I need that location as the X and Y coordinates for my rounded rectangular cut I'm going to make. And by the way, you'll notice that when things are nicely aligned like this horizontally, the Y value over here is going to be the same as the Y value here. So we can save ourselves some time by just reusing the Y value. When you have two things that are vertically oriented, you can reuse the X value. And then I need to calculate what is the height and width of each of these buttons, and they look to be the same, so I can use the same value for both of them. But what I'll do is I'll go up to this corner and get the X and Y location here. And it's approximately 392 in the X direction. So all I do is subtract 252 from 392, because 252 is what it was down here. Up here it's 392, and that gives me a nice value of about 139 pixels wide. Also, the Y value, remember Y is coming down from the top, so I expect this to be smaller than what it is over here. So the Y value, I can even take the measurement here. The Y value here, 1354, should be less than the value here, which was 1493. Just write all this down as you take these measurements. So I'll subtract this value from this value, and when I did that, I got about 139 again. Now, if you said 139, I bet these are really 140 by 140. Yeah, you probably could say that too, and it would produce a fine result. So I just take these measurements of the XY here, the XY here, we're using the Y. I've got the height and width measurements, and I'm ready pretty much to cut these two holes. So we'll go back to our form, and because I was taking these in pixels and I was doing them inside the screen region, I'm going to use the screen openings file instead of the case openings file. So again, I'll have a rounded rectangle. In fact, I'm just going to copy and paste this line a couple times. And gee, it would actually be smart to do that after I've put some of the values in, because I'm going to be reusing many of them. So 252 is the X for the home button. $14.93 for the Y location. The width I said was 139. If you put 140 in there, I don't think it's going to make any big difference. But they are nice and square, so we'll keep them square. And I've already got rounded rectangle as the top, or as the shape type. What I think I'll do here is I do want to provide some amount of slope down. Let's experiment just by putting a 60 in here, because that's what we often use on the cell openings in the grid. And I'm going to leave these other ones at 90 because the program doesn't care about them. It only, on a rounded rectangle, it only cares about the top slope. The corner radius, I'm going to guess at 15. Remember that all of these measurements are either in pixels or millimeters, not both. So when I use X and Y in pixels, I have to estimate corner radius, for example, in pixels as well. And the best way to do that is just by trying something and seeing how it looks. So now I'll copy and paste that. And as the instructions say up above, the last line of data shouldn't have a comma at the end. So this is the data region down here, and the last line shouldn't have a comma, but all the rest should have commas. What do I want to change here? Well, now we're at the back button. It's a little bit further over, so it's not 252. When I took the measurement, it was 418. But everything else is the same. So I only had to make that one change. And we'll go back and look real quick. Nothing here yet. Let's just go ahead now and save this file. Let's go back and look. Now we see our cuts, but we also see something that we probably don't want to go with. So you'll notice that by making these a 60-degree angle, that 60-degree angle kind of cut into the space of the other button and left a really low ridge in the middle. So we can't be angled at such a lazy slope. We have to take it a little bit higher than 60. So having experimented with this already, I know that a decent value here for the slope is 80 degrees. We still get a slope, but we don't start cutting into the space of the other button. And we'll save again. Go look at what we produced. Okay, so now the angle's a little bit straighter, but we do get now a full separation between these two buttons here. All right, now what we want to do is put a bump. Let's put a bump right here. And let's find that spot. The bump here, the X and Y location for a bump is the center of the bump. So let's go find that center in our screenshot. I'm going to zoom out just so I'm sure I'm in the right place. So this is where we'd like to put our bump, right in the center of that. And that looks to be around 817. Well, when I measured earlier, it was 817 and 1041. I could zoom in and get a little bit more accurate measurement. 817. Whoops, I'm in the wrong place. That's why. 817. Look in the lower left-hand corner here. 817, 1041. As I eyeball the center of that little space there. Note that because we've got a rounded rectangle corner, I've got a nice platform to put that button on. If I use straight rectangles, I may not have a nice flat area here for the button. So that's one of the benefits of rounded rectangle openings. So let's go ahead and add that bump. Still in the screen openings. I'm going to change this to bump. And it's got an X and Y location of 817 and 1041. Now for a bump, we care about it says here it uses the X, Y for the center of the bump along with a width to determine the diameter of the bump. So this is the one we want to fill in as width. And we're still using pixels here. So if you don't have a real good feel for pixels, and I certainly don't, you just kind of try something and see if it produces what you want. So let's try 20 pixels. See what happens. Save it. Back to our image. And there it is. That's a 20 pixel diameter bump. I think that's a little on the small side, but you will know your clients better, and that might even be the right size to not take up too much space or make it too hard to navigate around this. But I'm going to make it bigger than that because it just seems wrong to me. I'm going to go make it like twice as big. So we'll say 40 pixels. Save again. And now it's much bigger. You can go as big as you want. If you go beyond this platform, your printer is going to have a little trouble printing it because it's going to be printing part of that button out in space and could actually result in a failed print. So do think about things like that, and don't put objects out in space up with nothing below them. 3D printers have trouble in that when you do that sort of thing. So our bump is ready, and the last thing we need to do at this point is put Eddie up here, Eddie's name, and that means we're going to be using some top text, T-text. And text cares about an X location, a Y location, a height, and then slopes. Why in the world would text need a slope? Well, we'll look at it here in a minute. And then it needs to know what the text itself actually is. So the height is going to be how tall the letters should be. And what I'll do is I'll just go ahead and put that text on there, and then we'll look at how these other things like height and slope affect things. So we're going to put Eddie right in here, and I would take those same measurements right off of this, maybe try and put it in the area where it says page 1. But let's go ahead and put that information in. So Eddie in quotes, double quotes, and X and Y location, 872 for the X, 1486 for the Y, and let's start with pixels high. If this is 20, then if that's 20, then how tall is the E in Eddie? Let's start with something like, say it's about 5 times as tall, so say 100. All right. Something like that, and we'll save it. See what happens. Ah, okay, look, I do see kind of Eddie here, but it's headed off this direction, and I don't want it to go in that direction. So what can I do to figure out which direction the text should go? Well, there, on the web page that talks about creating hybrid and fully freeform keyguards, this picture here shows you what text is going to look like with various kinds of rotation, and the rotation amount is what's going to appear in that top slope column. So we have a 90 there. That's why the name kind of goes vertical on us. We would like it to go horizontal, so we're going to change the 90 to a 0. This 90, let's get rid of the 9 and save it. Now Eddie extends out as we would like, and is nicely horizontal. But if we wanted, we could easily, go upside down with it or go vertical with it in one way or another. Depending on where you place it, you may want to go with these kinds of other rotations. So we've got the bump, we've got Eddie on top, and I guess the next thing for us to do is to round these corners and put the text on the bottom. So let's look and see where we wanted that text on the bottom to go. We want it to go out here, outside of the screen region. So the most convenient place to put that information then is in the case openings info file rather than the screen openings. So let's go back here, go to case openings. We'll say that we want to put text on the bottom, which means B text. And this, when you're putting text on the bottom of something, I just find it easy to kind of just try some things and then adjust the numbers until I get what I would like. For example, remember that this is what it looks like from the top. Here's your camera opening. Here are your two buttons in the command bar, and this is for cases. This is 00 here. When I flip that key guard, that means that here's your camera opening, here are your two buttons. That means 00 is here. So my text is going to have an X and Y location in the lower left corner of this piece of text. That would be right here. So it would be some small amount in the X direction and a fair amount in the Y direction. So we'll just try something and see what it looks like. So a small amount in the X direction, and we're in millimeters, we're not in pixels anymore. So let's try 5 in the X direction. Helps to know the height of my case opening, but let's just assume, say 40 in the Y direction because we know it's larger than the X, and we'll set our height to, remember, millimeters now, not pixels, so a smaller number goes a long way. We'll say 5 millimeters. And the text is SN space and then the date 2019, 02 for February, 15th for the 15th of February. That's when this was designed rather. And we'll just leave the slope because let's find out what happens. So we'll save it. Go back and look at what happened. Let's turn this key guard upside down. Well, not terrible. Not terrible, except we wanted the text to go the opposite direction. So let's make it go the opposite direction. Instead of 90, let's say minus 90. And let's go look again. Okay, so now it's looking more like what we had talked about it needing to look like. It's extending down in this direction. Let me see if I can turn that key guard around so it looks kind of like this picture. Get around here. So now it looks it's kind of positioned where we want, but we need to get it further in, make the X dimension larger, and I believe need to make the Y dimension larger as well. So let's double that X dimension, say 10, and let's just take you up, I don't know, let's say another 20 to 60 millimeters, and save. All right, now it's looking pretty much like what we wanted, right? You'll also notice that the text especially appears kind of jaggedy and sloppy. And that's because the program is just trying to render it as quickly as possible. We can make a prettier text by rendering it. And it'll take a moment. We'll see a progress bar here on the bottom. And you don't need to do any rendering. It's just, if that annoys you, just render it. The amount of time it takes depends on the horsepower of your computer. Mine doesn't have a lot of horsepower, but now the text looks a lot prettier. All right, so we've got the text on the bottom. We've got everything looking pretty good on top, except we were going to round these corners. And to do that, we're going to use a concept called an outer arc. So let's look at that. It's up here. So this is exactly what we want to create. We want to create these arcs here that kind of cut off and round these, soften these outer corners. And an outer arc has an XY location just like anything else. The X is really the point that you want to round off. So we'll be able to calculate those in a second here. And there are 4 different kinds of outer arcs. Let me see here, where is it at? And really they're just counted by quadrants of a graph. So there's an outer arc 1, an OA1, an OA2, OA3, OA4. When we're looking at these guys right here, this is going to be a cut that looks like this. So that's an OA1. I'm sorry, that's an OA, yeah, that's an OA1. It's in the first quadrant. This is an OA2 because it's going to cut like this. And the last thing we care about is how far the cut should go. And you just need a gentle enough cut so you're taking that sharp edge and kind of rounding it a little bit. So again, this is out in the case region. So we'll be adding these to the case file, the case info file. And where do they go? Well, there's going to be one right here, where right now this kind of cuts in sharply, and we just need to know the distance. Well, it's 225 to the edge of this cut. 225 in the X direction, 35 up in the Y direction, and 35 plus 90, 125 for this guy up here. Those are the 2 tips of the this is 35 up, this is 125 up. They're both 225 in the X direction. So now I just have to enter that information into the file here. So we needed a outer arc 1. This is the one that's going to be on the bottom. So it is, well, they're both at 225 in the X direction. In the Y direction, because this guy's on the bottom end of the opening. So it's got the 35. And we're going to use we're just going to go really gentle with this corner radius to start with. We'll just use 2 millimeters. And we can have a slope here on this, but again, the outer edge of the keyguard is a 90-degree cut, so we'll leave it at 90. And I'm just going to copy this and paste it again. But I have to remember that the last line of data shouldn't have a comma at the end, but every other line should, so I have to put a comma here. This one's okay to have no comma. In fact, I should have no comma, but this one I have to put a comma at the end. So the other one I think I said was an outer arc 2. And it's not 35 high, it's 35 plus 90, 125 high. heck, let's see what happens. So here we are. We've rounded our corners. One there, one here. They've been rounded nicely. So now we've produced, by the way, anytime I make a change, it does a quick render again, so the text won't look great. Sometimes you'll see little images kind of hanging from corners, especially corners that have been cut. And this can all be cleaned up just by doing a render. But again, it's just not important to do a render until the very end, because it takes time. But we basically got our keyguard here that we want to print out. It's ready to go. It's got all the components we were looking for. And because I actually have some yellow filament and some green filament, though not exactly this color green, I went ahead and printed this keyguard in yellow and green filament. I swapped filament. I started in yellow, then swapped over to green, and then swapped back to yellow again. So we'll take a look at what the actual keyguard looks like. So here it is, final keyguard. The green isn't as nice and dark as the image, but pretty close. And here's the serial number right there. The cutout with the rounded edges. Ready to go.